Year 11, this is exercise 4C on the graph of y equals the square root x on page 151 of your textbook. Now we've been looking at the idea of the rectangular hyperbola and also the truncus over the last few sessions. This function is actually slightly different, and it's very important for us to be able to distinguish this type of function from the others. Unlike the other functions, the square root function does not have an asymptote. It does not have an asymptote. It is possible for this line to pass through any point. However, it has a starting point. And the reason is because, remember, a square root of x, remember if I substitute the value of x, the square root of whatever's in the result of inside the square cannot be a negative number. If we have square root of 1, that makes sense. Square root of 0, that makes sense. But I can't have the square root of negative 1 because no matter what value of whatever value I have, I can't square a number in order to get a negative number, at least not a real number. So I'm going to go ahead and do the same thing we did last lesson with giving a function and subbing in the points. I'm going to go ahead and use a basic example of y equals to square root of x. Now you can see here, the general forms are here. The same thing. All we're doing is instead of writing the square root, we're writing this power of a half, which hopefully you remember from our index laws. But let's go ahead and substitute these values. Like I mentioned, we cannot have x being negative 1. X cannot be negative 1 because it doesn't exist. Remember, it's not that it's equal to 0, it just doesn't exist. However, the square root of 0, if I was to substitute x equals 0, the square root of 0 is indeed just 0. Square root of 1 is 1. Square root of 2 is, I don't remember off the top of my head, I think it's 1.3 something, but you get the idea. As we increase the value of x, it's going to increase the value of y. But you might notice, also in this diagram up here, you might notice that the function increases at a slower rate. It's a sideways parabola. However, it only shows one of the halves. So you can't have both of the halves in the same function. I'll explain what that means in a second. Let's go ahead and put this into our graph. So we know that it starts at x equals 0, y equals 0, goes up to this point, and then as I keep going, it'll slow down but still increase. So my function ultimately looks something like this. It's just a sideways parabola. Now theoretically, because there is no asymptote here, theoretically it is possible for this function to continue on forever and have a y value that is, let's say, 100. Right? There is no asymptote as opposed to the other functions we've looked at over the last few lessons. So that is the square root function. If you wanted the other half of the square root, so of the parabola, let's say, so for example, if you wanted this half, all you need to do is you need to allocate a negative in front of the value, so y equals a negative square root, and we have our reflection. In that sense, then we end up with the other half of the parabola. So a square root function means that it only starts at a certain point and continues in one direction. But if we want the other side, we need to make sure we add a negative for the reflection. Once again, put this into principle by trying to sketch the following. So we have y equals 2 square root x plus 1 minus 6. As you probably would have guessed, the first thing we do is recognize that minus 6 means that we shift down by 6 units. And you might have already guessed that the plus 1 means we shift left 1 unit as well. So we're shifting left 1 unit, we shift 6 units to down. Now there's no asymptote, so we don't start with asymptote. I am going to draw my Cartesian plane as per usual. And then I'm going to go ahead and find out what key points we know. So I know that instead of starting at 0, 0, like we did before, we're going to go ahead and start, well, 1 unit to the left, 6 units down. So 1 unit to the left I'm going to say is here, so that's a negative 1. 6 units is there, so I'm going to say there, and we end up with this here. Now I'm going to go ahead and find my y-intercept. So my y-intercept, just like we normally do, we just go ahead and let x equal to 0. So I have y equals to 2 root 0 plus 1 minus 6, which gives me y equals to 2 times square root of 1, which is just 1, minus 6 equals to negative 4. And so my y-intercept is going to be at negative 4. I can find my x-intercept as well. So I'm going to go ahead and do that by looking at x-intercept being where y equals to 0. And we end up with 0 equals to 2 root x plus 1 minus 6. I should stop writing diagonally. And then we end up with adding 6 on both sides. We get 6 equals to 2 root x plus 1. Dividing both sides by 2 gives me 3 equals the square root x plus 1. As you probably guessed, the next step is going to square both sides. We end up with 9 equals to x plus 1. And then finally, we're going to take away 1 on both sides. We get 8 equals to x. And so I know that my intercept of the x-axis is at x equals to, let's say, about here, where x equals to 8. I know that I can connect the dots, and my graph is going to look just like that. So the idea, remember, a few key points to take away, is that our square root function is going to be half of a sideways parabola. It is only one half. It's not possible to draw both of them using the same function. So we're going to have that. Our function does not have an asymptote. It is possible. So right now the domain of my function, my domain, may only be from where x equals to -1 up until infinity. But my range is also going to be where it's going to go from -6, which is this lowest y value, all the way up to infinity. Okay, best of luck.